We're going to move into a section on new digital business models, of which, like you can imagine, there is a shortage these days. We have 3 talks from some of our colleagues here at MIT. The first one is from Christian Catalini, who's going to be talking about a topic we've heard brought up a couple times already today, and a deeper dive will be extremely valuable. This talk is about blockchain and cryptocurrencies and their impact on the digital economy. Christian, over to you.
Hi, everyone. I know we're just in that phase of lunch where digestion is kicking in, so I'll try to bring you all back. Sandy's talk was actually fantastic because it introduced many of the topics that I plan to touch on as I introduce blockchain. We got interested in this topic actually a few years ago, between 2013 and 2014, when we distributed about $500,000 in Bitcoin to every undergraduate student at MIT. Everybody was surprised that our students weren't spending their Bitcoin. Only 15 to 20% actually tried using Bitcoin. The vast majority, as of today, is still holding. You may want to know that those $100, the slide is actually outdated. As of today, it's about $800 worth of Bitcoin that they have. So I think they made a wise decision. The phenomenon has actually evolved away from Bitcoin, which is kind of the first implementation at scale. And the term that you're hearing more and more from the financial sector, from regulators, is blockchain. The two are actually tied, and I'll try to unpack some of that. This is joint work with Catherine Tucker and some of my other colleagues. As you can see, the interest in this space has been exploding. And as the phenomenon has moved really from the fringe, from the pirates, right? So the hackers and the cyberpunks to the mainstream. Here, the cover of The Economist was kind of one of the first to move away from the currency aspects and towards this idea of a giant time-stamping machine that can generate a perfect audit trail, something that's actually quite valuable in society. And more recently, the financial sector, the woman that you see up there is Blythe Masters, veteran of JP Morgan that decided to quit her job to essentially revolutionize how exchanges work every day by using this technology. I think that was paired with a lot of hype. And so if you take your airport book on the way back, I think you may leave with the perception that there's a revolution coming. My note of caution is that most revolutions either fail or take a lot of time to succeed. And even if you look at where Gartner places cryptocurrencies on the hype cycle, we're coming down from the peak, maybe not. It's interesting to see that this is the first time they put it on the graph. It didn't exist before, so they kind of retroactively add these trends on their curves. The first thing to keep in mind is that there's many competing standards in this space. And we're going towards what I'm calling the dot-coin bubble. There's a lot of hype. Many of these protocols haven't really shown market traction, but there's a lot of interest. So Sandy was mentioning the crazy Bitcoin. Well, crazy Bitcoin is worth about $40 billion in terms of market cap as of today. And you can think of that as a giant bounty on anybody that can try to hack into the underlying aspects of the protocol and try to steal some Bitcoin. But there's many others that are actually much more, more traditional in terms of their origins. Ripple is much more friendly to the financial sector as we know it, and there's a lot of experiments. Even within Bitcoin, which is kind of the largest blockchain out there to date, there's a fierce battle for the standards. The two curves, this is a picture that I took yesterday. The two curves are two alternative versions for that standard. The yellow line wants it to be a store of value. Think of it as digital gold. The green line is pushing for it to become a faster and more efficient payment system. And of course, those two things may not well coexist on the same chain. About $1.5 billion have gone in terms of VC money in this space. Nothing has come out yet. The reason being that there's a high degree of entrepreneurial experimentation, and we're really in the infrastructure building stage. You have to roll back to the internet in the early 90s, and so think about the Netscape moment hasn't taken place yet, or maybe it did a few days ago, but I don't know yet. So I'd like to take a step back and ask, where's the breakthrough, right? So when we look at this technology, why should you be interested? So let me give you a really quick definition, and I only have 20 minutes. So for the purpose of this talk, a blockchain is going to be a chain of blocks, okay? So very simple. What's going to be useful to think about is that those blocks can represent many things. You can place transactions in them. You can place some form of digital IP or some form of digital asset. And for now, you'll have to believe me that as time passes, a mix of cryptography and game theory, mostly it's actually game theory, makes that chain very hard to change ex post. So it becomes kind of a perfect audit trail of a marketplace. Why I'm excited is because for the first time, you have economics and market design, so how we think about platforms and marketplaces, mingle with computer science in a very profound way. And also how we think about law and contracting. So this is a technology that is going to impact these three large verticals in quite interesting ways. So when we started studying this, we cheated, which is what economists always do when they're faced with a technology they don't understand. There was a lot of hype out there, and so we said, look, if we can identify fundamental costs that are affected by this technology, maybe we can start thinking about use cases and say, is this a use case that requires a blockchain versus not? And so we landed on two, and this is very much work in progress. The first one is what we call the cost of verification, and I'll elaborate on that in a second. The second, in the absence of a better name, so there's a naming contest if anybody has an idea, we call it cost of networking. And I'll try to unpack them in the next few minutes. In fact, Sandy touched on a lot of this. So what do we mean by the cost of verification? So in society, from the moment you wake up and you check your email, you're essentially performing transactions. You're authenticating yourself, you're exchanging goods, you're ordering something off of Amazon. Every interaction in our society is a transaction. And those transactions are born with some important attributes. Who's involved? What are the credentials involved? Do they have enough funds to perform the transaction? And most of the time, marketplaces just run smoothly, right? Think about your own transaction. Most transactions go well. Everything is fine. But every now and then, we have an exception. Something goes wrong. And society copes with something going wrong by performing a broadly defined audit. Sometimes it could be auditors coming into your firm and auditing books, but it could be someone having to run a labor-intensive process or checking some accounts or balances or your credentials on your CV, whatever it is. It's usually expensive. Now, what blockchain changes is that if you can accurately record those attributes early on a distributed ledger, verifying them, it's costless. So that's why we call it costless verification. Of course, it's never going to be zero, but it's zero, you can keep in mind the way Wikipedia changed kind of, the online diffusion of knowledge. Of course, contributing to Wikipedia is not zero cost, but it qualitatively changed how we provide a public good like an encyclopedia. The other issue is that society today copes with all these attributes, all this information being necessary for executing transaction by leaking it at every stage. And this was very much what Sandy was talking about. So to avoid information leakage, we need a system where that information doesn't kind of depart the mothership in the first place. Just look at this is the recent data for data breaches. They're increasing, and they touch government, they touch private firms. It's almost impossible in a digital environment to keep our data secure, so maybe a better model is not to have that data leave in the first place. The other thing that you can do with a blockchain is that you can ensure data integrity. As I mentioned, cost of verification goes down, so we can do more verification. And that's good to society, because transactions that we couldn't support before suddenly are economically feasible. Here's where it gets interesting. For the first time, we can create scarce digital property. In the digital environment, if I'm sending you an attachment, I can send that attachment over and over and again. Digital goods, by design, are hard to make scarce, right? That's a terrible property if I'm trying to send you a banknote. Right? That's what is called the problem of double spending. Here are two examples with Bitcoin and Ethereum to create scarce digital property in an environment to create a marketplace. And I don't have enough time to go into the details, but for now, believe me that the first one allows you to create a store of value that is scarce, and the second one allows you to perform a computation, which is also a scarce resource in society. The second cost is what we call the cost of networking. And here I want to take a step back and highlight what I think is the breakthrough innovation behind blockchain. The idea of reaching internet-level consensus. What do I mean by that? Think of it as a technology that allows a network of devices. It could be machines, it could be robots, it could be computer servers, individuals, to agree at regular intervals about the true state of shared data. Okay? That shared data could be a ledger, like in the case of Bitcoin. It could be something like much more complex. Think about electronic and medical records or IP. Now, if you put those three things together, a network of devices that can agree at regular intervals about shared data, you're very close to having a platform. Right? When you think about any intermediary on the internet, it's somewhat a composition of those things. And so that's where the technology is actually more likely to be disruptive in the next 15 to 20 years. Of course, you could argue, look, we had the ability to crowdsource ideas, talent, resources online for a long time. But the challenge has been that we created intermediaries that have a high degree of market power as a consequence. In fact, on the internet, we're all renters, right? We rent resources, we rent services. Nobody owns their data. And that's part of the problem when it comes to privacy, too. As a result, these intermediaries have largely benefited both from the direct network effects of their platform, but also the indirect ones. Think about all the applications built on top of the Apple App Store. And the consequence of market power are familiar to economists. The first one is going to be prices. But here is also in terms of ownership of the data. When you send a message through Facebook Messenger, Facebook gets to read the content of the message. While at the same time, all that's happening is essentially a peer-to-peer transaction of information. Why do we need the intermediary in between? Because they run the platform that allows you to connect, right? It also creates a single point of failure. Just look at recent events, right? When we centralize everything in the cloud and an engineer types the wrong thing on the console, suddenly the East Virginia servers go down and a bunch of websites go dark. It has also created lock-in. In all this platform, we're embedded. All our content is in those platforms, so it's difficult to move around. And this may have reduced innovation. At the eye level, this is an architectural change. Rebecca Anderson and Clark have this seminal paper in how they kind of try to classify different innovation in terms of the impact on value chains. I think what blockchain is about to do is to radically change how we create value and capture it in a digital environment. Because now what you can do is create a digital token. Think about Bitcoin as an example that allows you to bootstrap an entire platform. You've created an incentive for early adopters to come in, fund your system, and also, over time, incentivize its operations. It could be money, it could be storage, it could be whatever other resource, energy, that you're trying to barter and exchange online. The reason Bitcoin is secure is because it's been bootstrapped through speculation. Speculation was the early use case of that ecosystem. Let me just drive a really quick comparison between SWIFT, which we are probably all familiar if you've sent a wire between banks across countries recently, and Bitcoin. So at the eye level, what's happening is almost like you're decentralizing the returns to those network effects. In the SWIFT example, the cost of securing that network is really the cost of securing those nodes, the banks. And that's why when SWIFT was breached last year, somebody was able to wire something like $80 million between two different places before they got caught. Those systems are currently very fast. So Visa can do something like 50,000 transactions per second. Bitcoin right now looks like a toy, 7 transactions per second. But if you go back, the history of the internet, scaling has never been the issue, right? If you were worried about images breaking the internet or voice over IP or even video, we always worked our way around scaling problems over time. The key distinction is that in the left setting, the ownership of the assets, right? So the example that came up before about banks and your currency with them, you have no ownership over it. In the Bitcoin world, as long as you're able to manage your private keys, and we'll see, I think, a rise of intermediaries helping you do that, you have full ownership of those assets. And those assets could be currency, it could be your medical records, it could be private information, it could be IP. Moreover, the environment on the right allows everybody to innovate on top of it without asking for permission. If I want to build some smart contract on top of Bitcoin, I can do it today. So let's go through really quickly, I only have 10 minutes, about some of the applications. You've heard a lot about, I think, the different spaces from fintech to new types of platforms, robotics. And again, a lot of this is really early stage, and the space is really hyped. So note of caution, these are proof of concept, and we're far away from the largest market implementations. Some have tried with money transfer, but as it turns out, remittances, the real cost of a remittance is usually the last mile. And that's why some of these services have struggled to replace regular remittance transfer systems with Bitcoin. Micropayments and crowdsourcing. Why isn't it the case that our browser has a digital bank account in it or a digital wallet where we can both pay for services in a seamless way so that we don't get hit by every paywall as we navigate around the web, but also get paid, let's say for answering a survey or for performing a task? Crowdsourcing, I think, will see a boom of activity where you can crowdsource ideas, talent, and labor on a global scale through any mobile device on the planet. Central banks, they're the big elephant in the conversation, right? They're all interested in this because it can impact how they do taxation, how they do quantitative easing. It totally changes what they can do with monetary policy, but there's a long road to get there. And regulation, of course, needs to adapt. Some banks are experimenting, Canada, Singapore, England. The Fed is much more conservative because there's a lot more at stake. Finance is the sector that really jumped on this. And these are just some of the examples. Ripple right now is one of the cryptocurrencies that have reached quite a degree of success. And their basic idea is just, can we connect a small corresponding bank in Germany to a small corresponding bank in the US without going through the intermediaries by lowering some of those transaction costs? So they've been successful with that. But there's experiments in stock exchanges and all sort of digital and financial assets. What's interesting is that Bitcoin was incubated online, and one of the early use cases beyond speculation was illegal drug markets. And that came with a lot of negative press, but when you think about it, those are markets where trust, reputation, and identity are paramount. You need privacy, right? If you're engaging in one of those transactions, the last thing you want is someone to be able to tie you to that transaction. It turns out that that's a very useful feature also for financial markets. And that's why 2 days ago, JP Morgan just made a large commitment to use one of these new zero-knowledge proof cryptographic currencies, Zcash, as part of its infrastructure. The idea is that if client A is transacting on my network, the last thing they want is for client B to be able to get some information through their use of the network. Healthcare data. Google's play with DeepMind, their AI company that they acquired, is really to convince you essentially to share healthcare data. And one way they can prove that that data is not used improperly is by using a blockchain. There's a lot of hype around smart contracts. I'm going to go really quickly because I think they're really early stage and very dangerous when we get them wrong. There's interesting applications also in supply chain, provenance, logistics. It works really well for something like a diamond, where you can get some physical properties, right, and record them digitally on a blockchain. It's not clear to me that it will work in settings like food and other settings where there's not a clear identity for the good that you're trying to track. And I think the rule here is a blockchain is only as useful as the data that you're bringing into it. So if you're recording bad data on a blockchain, it's going to be as useful as what you had before. Digital rights. Spotify recently acquired MediaChain. The basic idea is to solve the mess that is the settlement and reconciliation of digital rights for artists in a seamless way across a group of actors that typically don't trust each other. The assets don't need to be as simple as digital rights in music. They can be more complex digital assets like private equity. NASDAQ is experimenting with bringing early cap tables of startups on a blockchain, so that eventually in 10 years, the companies may be able to be born on a blockchain and go IPO on a blockchain all in one step. There's also an effort to build a new internet. So the 5 lines of code that you see on the top right are all that would be required to build a domain registration system that does not allow anybody to censor the internet. It's also a system that would be much more resilient to our DVRs and webcams waking up and attacking us back, like it happened a few months ago. The internet infrastructure wasn't built for a world with billions of devices. And so we need to rethink how centralized some of this infrastructure is. Going back to the cloud example, the cloud is a fantastic solution, and it lowered the cost of experimentation for a number of startups, but it comes with a high degree of centralization. And that's why one typo can wipe out $150 million in a few hours. Again, cryptocurrencies haven't had their Netscape moment. 2 days ago, one of the startups in this space launched a browser that's going to run entirely on a decentralized ledger. What that means is that your data is never stored with any provider. You own your data. You use services where your data is under your control. And again, use cases are still fairly limited, but you can see where this is going. Here's some of the things you can do. Let's say you have a cryptocurrency, and you tie it to a physical resource. Let's say disk space on your drive. So the left side is what you're all familiar with, right? We buy, rent space in the cloud to back up our files, to share files. But what if we surfaced all the capacity that's out there and underutilized, kind of like what Uber did for the cars, and at a marketplace to barter and lend resources online? That's what Filecoin is trying to do. Link a crypto token to an asset, in this case, disk space. You can link sensors, and suddenly you can have a marketplace, maybe for environmental or other type of data that you're trying to collect. That data stream can be monetized instantaneously. Of course, if you go further into the future, your self-driving car could be buying up lane space when you're going to work, if you're running late, from your peers. I mean, that introduces all sort of perverse incentives for people to just drive around and slow you down. But you can see machine using these platforms to transact in a much more efficient way. I want to land on one last example, mostly because this really highlights how cryptocurrencies are here to really change the nature of the firm. How we allocate resources, source capital and labor and ideas. Numerai is essentially trying to do this in the hedge fund space. And this is actually something that most of it you could have done before. It's not that different than crowdsourcing. They're saying, we're going to take financial data, we're going to encrypt it, we're going to give out to the data scientists. The data scientists are going to compete in what is essentially a Kaggle competition and make predictions. Where it gets interesting is that Numerai is actually giving these data scientists tokens. These tokens are used by the data scientists to make bets. Now, all your incentives to overfit your data are gone, right? Because you're an equity holder of this cryptocurrency itself. And why that is interesting to economists is because you suddenly solved Arrow's paradox. The fact that if I have information, in this case, my model for predicting the future, the moment I show it to you, it's gone. So you can combine a cryptocurrency with AI, in this case, and create new types of marketplaces that I think will change how we do a lot of things in society. Thank you very much, and I'll take questions.
Yesterday, one of the speakers said he thought it would be 20 years before blockchain was really integrated into our computational systems. What do you think?
So, yes. I would say that, as much as I'm worried about the dot-coin bubble that is warming up, if you've been tracking the recent movements, all cryptocurrencies are going up by 40% a day, which is clearly not sustainable. There's research actually by Ramananda at HBS that shows that when society goes through these bubbles, as costly as they are on other dimensions, they do spur a wave of innovation. So, it's going to mint some crypto millionaires, and some of that investment will be fed back into the system. So I think there's a huge issue on the regulation front, but some of these protocols are quite interesting. And so, we don't have commodities today for digital goods like storage. And this is filling a void. So I would say it's probably going to be faster than 20 years. I would say 5 to 10.
I'd like to follow up a twist on what Jerry's just asked here. The thing that struck me was the asymmetry between a SWIFT and the blockchain, although, as you rightly point out, these things scale. Help me think through the notion of blockchain as a subroutine or a part of another platform. Like if I was running Slack in an organization, I have decentralization, and there may be certain things I don't want to share. And so it's still Slack, but I am blockchainifying it. That's what I want to get a sense of. How can one create blockchain as part of an ecosystem as opposed to the dominant platform?
So first of all, I would preface the answer by saying that we're not going to put a blockchain everywhere, right? So there's economies of scale in many applications. And so I think the trade-offs are really around privacy, verification, and when do you want an open protocol? To your example of Slack, Slack now needs to prove that they're not able to access the conversations of the people using it, right? So that would be an example where if I'm Microsoft or if I'm anyone else, I don't want that data to be out because that data could be mined. And so you could have a system where a blockchain could add value, but again, you could do it with private keys today. So I think it's really important to think about where is that kind of network and marketplace adding value to. So one advantage could be, for example, if regulators wanted to be able to access your Slack chats ex post, right? And so if you need to keep an immutable trail where you're not able to go back and revert it. So it really depends on the use case. Slack doesn't strike me as the first one, but I think it's interesting. No, it's really interesting to think about. You could take something like Twitter, and so should Twitter be more of an open protocol than it is today? And I think that's an open question.
Fantastic. Christian, thanks very much.
Thank you.